Welcome to tutorial number 13. It's about the overdrive function and about drawing curves in CrusherX. Curves you can also use as a modulation source or as a grain window type. Let me open the spline curve window by clicking the Drive button in the vapor field. The x-axis represents the input volume and the y-axis represents the output. The blue curve runs linearly through the point of origin. The angle is 45 degrees, meaning the output is identical to the input. No overdrive is going on at all. Don't care about the figures. Both the x-axis and the y-dimensioning are meant to be equal. It's just a bug, but it isn't important here. A lot of Waveshaper VSTs don't even have a dimensioning of the axis. It is the angle of the curve that is important. The red curve represents the default overdrive function. To apply this function to the sound, I increase the overdrive offset slider, and while I am doing that, the blue curve approaches the red one until there is only the red overdrive curve left at 100% overdrive. The overdrive curve is quite steep in the near of the point of origin, meaning a little more input volume results in a lot more output volume. The input is amplified up to distortion. As this video is about the functionality of CrusherX's overdrive function and not about overdrive and wave shaping in general, only a few sentences. It shall be sufficient to explain overdrive and wave shaping here. The term wave shaping is used to describe the fact that by distorting a signal, the shape of the signal of the wave changes. It gets a different shape, of course. Musically, it means additional or different partials occur in the spectrum of the sound. The input, here in my examples, is a clean sine wave. The external oscillators attack and decay are high. So we can nicely observe the changing of the wave's shape while the input volume increases and decreases. Please look at the thin white arrows in the spline graph. They depict the development of the spline curve. To remove a point, you have just to right-click it and drag it out of the spline window. As Symmetric was switched on, everything I did in the one part of the coordinate system happened in the other part of the system as well. I switch Symmetric off and insert a point. I switch Symmetric on again, and the newly drawn point appears on the other side of the graph as well. There are two kinds of points, spline points and knee points. To insert a spline point, I just right-click in the graph where I want the point to be. Then I can drag the point around with the mouse to change the graph. To delete it, I drag it out of the window, as mentioned before. A spline point acts like a gravitation field. It deforms the curve, pulls it into the direction of the spline point, but the curve doesn't go through the point itself. Spline points are used to get smooth curves. To add a knee point, you hold down the Shift key and right-click in the graph. The curve goes through a knee point. You draw sharp peaks using knee points. Of course, you can drag knee points the same way as spline points. You can't drag any point, neither a knee point nor a spline point, across the x value of a neighboring point. When holding down the Control key on the computer's keyboard while dragging a point, the X value stays the same. You can change the Y position, height of the point, but not the X position. This is useful if you want to change the amount of overdrive of a certain input level. At a certain input level, of course. With Symmetric switched off, you can hold the Control key and drag the first or the last point in the graph. This will set both points to the same Y level. You can create a clean, cyclical kind of overdrive this way. Holding down the alternate ALT key while dragging a point, its value will jump from grid point to grid point. Do you remember my video about the grain view? It is tutorial number 5. The right mouse button has got the same functionality here. Click it once, changes the mouse to zoom mode. Click it twice, lets you shift the drawings around in the window, and clicking it again returns to normal mode. Reset creates the default graph again. I switch reset off again and draw in a single knee point. The button mirror mirrors the whole graph along the y-axis. The button invert mirrors the graph along the x-axis. The create function offers 9 different drawing algorithms. In front of the create button there is a small window to set the number of steps the drawing algorithm shall include. The algorithm line is a little bit special. I will deal with it later in this video. We see that the other 4 algorithms are 2 times mentioned in the menu. That is because each of them can include the set number of points as spline points or as knee points. See earlier in this video. Let me set the number of steps to 10, switch off Symmetric and choose the algorithm steps up. We see that, indeed, all points are acting like spline points, dragging the curve into their gravitation field. I reset everything. And now I try knee steps up and I get a wonderful Stairway to Heaven. Well, no, Led Zeppelin was earlier. Now it's CrusherX. Sorry for the bad joke. Well, I had to reset everything or undo some steps. I will talk about undo in some minutes, because applying the other version of the same algorithm doesn't change anything. Example: steps up plus knee steps up or contrary won't change the graph. But when I change the number of steps, the new points are added to the existing graph. Let me add 4 new points and, this time, use the algorithm knee step up. The rule is, when I apply more algorithms one after the other, CrusherX doesn't change the points in the graph which have been created by earlier applied algorithms, but adds the new calculated points to the graph. Only the first and the last point in the graph may be changed depending on the new algorithm. I will reset everything and demonstrate this rule. You will see that existing points are not overwritten except for the first and the last point in the graph, but every algorithm adds its own points to the existing graph. But what about the algorithm line, the first in the menu? Well, line places the set-adjusted number of points exactly along the x-axis. I will use 10 points for the line algorithm. I reset everything to show a second example. The points created by the line algorithm are spline points, but they have, let me say, a very strong gravitation. Of course, the create algorithms work different with symmetry switched on or switched off. At first, symmetric off and knee steps up. And now symmetry on and knee steps up. I am going to create some special curves now. A sine curve first. Symmetric must be switched off, the number of steps or points has to be 4, and the algorithm is zigzag. A sine half wave now. I reset all. I choose only 3 steps and set the algorithm to zigzag. I invert the curve, and here it is. With knee zigzag I get, of course, triangle curves. With only 2 points I get a horizontal line, what means the y value is always 0, no output at all, no matter how loud the input is. I use this horizontal line, zoom in a lot and draw a very small but high peak. I zoom out again to show the dimensions. And a couple of peaks more. minimum number of steps is 2 and the maximum number is 100, what is really a lot. What about that? You can save and load curves. The undo function is fully implemented in the handling of curves, whether it is on the deep level of drawing a single point, or on the level of handling the whole drawing. Included loading another drawing. Let me talk about the positive and the negative, the plus and the minus part of the coordinate system. To do so, I draw a V with its basis exactly at the point of origin of the coordinates, the 0 point. Please look at the oscilloscope down left to follow the next experiments. As a result, the negative half waves of the incoming sine wave are mirrored upwards along the x-axis. There are no negative half waves anymore, but the frequency is doubled. When I invert the curve, the positive half waves are mirrored downwards along the x-axis. When I draw a horizontal line and drag it upwards, I get positive DC offset. When I draw it down, I get negative DC offset. I want to demonstrate the tip on page 13 of the manual as a last experiment in this video. It anticipates the matter of modulations, but as modulations are going to be my next subject in video 14, you may understand it as a kind of crossover. I create a complex curve. I turn down the overdrive's offset to 0 and its modulation depth to 100%. I choose saw up as the mode of modulation. I increase the number of generators to 2 and set one of the phase sliders completely to the left, the other one completely to the right. You see and hear that the two stereo channels are at different stages of the modulation. Thank you for watching. If you want to support my work, please subscribe and like and share the video. Have a good time, Rolf.